Hello everyone, welcome to Pi Unboxed. This is episode 13 of the series where we are building clone of PDF.AI app. So by the last video, it would have been pretty clear that searching between two strings and trying to find common words might not give us the best result. So we are going to change our searching strategy a bit in order to find the most relevant facts. We are going to use a different kind of search referred to as semantic search. In semantic searching, we are really trying to understand what the user is trying to get at, what the question they're truly trying to ask, even if they don't phrase it in the best terms possible, or even if they don't use the words we actually expect to. So we are going to implement semantic search using something called embeddings. We very briefly spoke about embeddings at the very start of the course. So now here in this video, I'm going to give you a much deeper introduction to this topic. Okay, so let's get to it. We are going to begin with a very quick exercise. I'm going to show you three different sentences. I want you to imagine that you are reading each of these sentences, and for each one, I want you to assign a couple of scores. The first score you are going to assign is a confidence score. This is a number between -1 and 1 that represents how confident or self assured the speaker of this sentence sounds. The score of 0 would indicate uncertainty, while a score of -1 would indicate uncertainty, while the score of 1 would indicate strong confidence. The second score I want you to assign is collaboration score. This is also a number between -1 and 1, but it represents how team oriented and or cooperative the sentence sounds. A score of -1 would indicate a independent behavior, while a score of 1 would indicate strong collaborative intent. In some cases, where the sentence indicate a strong preference for working alone or rejecting help, we might even allow a collaboration score. We can give a collaboration score of -1. So now here's the first sentence. I know this algorithm scales perfectly for our use case. Let's pair program the optimization. So take a moment to decide on your scores. So for confidence, we can probably say that this person sounds very sure of themselves. So a score of 1 sounds good. And they also want to work together. So collaboration score would also be 1 in this case. Okay, let's go to the next sentence. I'll spend some time on the weekend experimenting on my own. This doesn't sound confident or uncertain because it is completely on working alone. So here we will give a score of confidence as 0 because we are not sure of uncertainty or confidence. Also, this clearly indicates that they want to work alone. So the collaboration score will be -1. Now, the third sentence, this might be a good solution, but let's run it by the team and see what they think. This one is a bit more subtle. It sounds like some confidence, but not a lot, maybe 0.2 for a confidence score. And they're suggesting to get others' opinion. So it's fairly collaborative. So it would be around zero point 0.8 for collaboration score. Now we can take these sentences and plot out a two-dimensional space. So maybe X represents confidence and Y represents collaboration. Then we'll take each sentence and treat it as a point in the space. Once we do that, we can start to compute distance or angles between these points. And that gives us rough idea of how similar or different these sentences are to each other. In fact, when you use embeddings in real life, you often don't measure distance. You instead measure something called cosine similarity. So here's how it works. Let's suppose we have sentence with the following confidence and collaboration score. Confidence is 1, collaboration is 1. That's going to land us right here in the graph, up and to the right. Now suppose we have a new sentence that also gets a confidence of 1, but this time collaboration of 0. This sentence would fall over here right at the x-axis. Now the first sentence had a vector 1 1, the second sentence had a vector 1 0. We could measure how different these vectors are using Euclidean distance, but it turns out that that's not always the best option, especially as the vectors get longer and longer and higher dimensional. So instead, a real common technique is to compute angle between these two vectors. So if the two vectors point in same direction, the angle between them is 0 degree, and we say that the cosine similarity is 1. And if the two vectors point exactly in opposite direction, the angle is 180 degrees, and we say that the cosine similarity is -1. And if the vectors are completely unrelated, the angles between them would be 90 degrees, and we would say the cosine similarity as 0. So that's how semantic search works with embeddings. We can take the sentences we are trying to match, turn them into a vector, and then compare it to the database of other vectors using cosine similarity. The vectors that are most aligned or mostly similar are considered as the best matches. The wild thing is that in real life, these vectors don't just have two dimensions like confidence and collaboration. They might have hundreds or even thousands of dimensions. And instead of defining the dimensions ourselves, we let the deep learning models figure out what those dimensions should be. They look at a massive data set and automatically learn how to embed text into an abstract space where similar meaning land near each other even if the word don't exactly match. So that's it about this video. In the next video, we'll exactly see how to use these model in practice. Thank you everyone for joining. I hope you liked it. If you did, please feel free to subscribe the channel. Thank you.